Good morning, guys. So I'm going to go ahead and apologize now. You know how much I hate hearing my voice on a normal day, so me being all congested is not really ideal, but just bear with me. Um, so I'm not there today because I'm at home with the flu, unfortunately, but we still need to get through this lesson so that we can get through this chapter before Easter break, and that way you don't have to drag this chapter through Easter vacation. So, if you have any questions today, I really want you to email me. It's rritchie at mymariah.org. So write that down. Feel free to email me any questions that you have, either about homework or the lesson or your assignment, whatever it might be. I will be around my house with my phone, which will give you my email all day long. So just make sure that you ask whatever questions you have so that you can do well, because you will still be having a quiz tomorrow. We'll review before it, or no, actually we won't review before it because I'm not allowed to come back till Monday. So just make sure you're asking me any questions that you have today, and I'll get right back to you. So first things first, let's look at your homework from last night. You had 25 through 40. So if you need, have someone pause the video so that you can take a look at your answers. Write down any that you have questions on so you can email me about them a little bit later. You can just email me the question number and what your question actually is. You don't have to, worry about typing all of the weird symbols and everything if you don't need to. I'm assuming that you'd probably, if you had questions on any, it'd be 36 or 38. So or the ones that were related to it. So for 35, you just had to factor the polynomials that they gave you. Whenever you got the 5x plus 4 times the 3x plus 4, and you had to draw a picture, you have to take into consideration that they said that this included a sidewalk or a pathway or something like that around it, which means you have to think, well, this is my extra, this is my sidewalk, and if I split these in half, because I have sidewalk going the whole way around, something like this. So 4 split in half would be 2 feet or whatever the measurement was on both sides, and on the sides and top and bottom. And then your 5x just goes on your long side and your 3x goes on the inside, and that's the measurements of your actual, I think it was a garden. If it wasn't, pretend with me that it was a garden. And then 37 said, what is the ratio then? You just take your 5 by 3, or a 5 to 3 ratio. So no matter if we multiplied this by 2's for our x values, it would still be a 5 times something and a 3 times something. So it's a 5 to 3 ratio. For 38, it was the same sort of deal. They drew a picture for you this time though, and they wanted to know what were the lengths. So you would factor out your polynomial. You saw on their picture that they had x's on both sides of your, I think it was a pool in that case. So each width here, 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 and here were worth x, so that's 2x. And this would be 2x. When you take those out, that gives you the inside measurements of 21 units by 31 units. That's where they got the 21 by 31 from. And then moving on, 39, you just had to substitute the value. It said let x be 5. So you just had to sub in your value and solve. You should get 1271. And then, can't remember, oh yeah, then number 40 said let x equal 7, and then you figured that out when you subbed in your values, and then you subtracted your let 7 value from your let 5 value, and you got a difference of 304 feet squared. So that was your homework. Let's take a look at today. So lesson 10.4 is really kind of combined what we've been doing. This is on special patterns. So think back when we were multiplying our polynomials last chapter, there was a section on special patterns that really just kind of gave us shortcuts for figuring these out. It's going to be the same type of deal today. So just real quick, if you recall, in that section when we were multiplying them, we found out that if we have an x plus y binomial times an x minus y binomial. Sorry, my pen keeps turning off for some reason. All right, here we go. So if we have the sum of binomial and the difference binomial, when you multiply them together, you just take your first value, you square it, and then you take your second value, square it, and it's the difference of those two things. So it's the same thing again here. We have the sum and the difference. So you just take this value and square it, and this value and square it, and you're using a negative sign, because a positive times a negative is a negative. And same thing for the last. 2x squared and 3y squared. Remember, you have to square your constant and your variable on each, so you end up with 4x squared and then minus 9y squared. So these were just shortcuts. We could have actually gone through and used FOIL. You would have found that your outer and inner terms ended up canceling out, and you would have been left with your first and last. Then when we were multiplying our special products, we also, or our special product patterns, whatever they were called, we also had the squares of difference and squares of sum. And remember, that looked like the A's, B's. It was x squared plus 2xy plus y squared. Or maybe they used a plus 2ab plus b squared, whatever variables they used, it was that same sort of deal. So this was for the positive values. And then for the negative, for the differences, we had x squared minus 2xy plus y squared. So in this case, our first term squared is 25 squared minus 2 times 5x times 2 would be 20x, and then our last term squared would be 4. Or, like we said, we could just go ahead and write this out if you're not comfortable with that. These are just shortcuts to help, eliminate some of your steps, because you'll start to notice these patterns. But if you want to double check it, you can just go ahead and write it out, 5x minus 2 times 5x minus 2, and use FOIL. Same deal on here, we're using our positive values. You end up with 9x squared plus 30xz plus 25z squared. So we're going to use special patterns, just kind of in reverse now for factoring. So a perfect square is an integer such as 36 or 121, which can be expressed as the square of another integer. So hopefully we know that by now. This is 6 squared, this is 11 squared. Those are perfect squares. So the product of a pair of conjugates is a difference of two squares. Remember, our conjugates were the x minus y and x plus y. So factoring a difference of square binomials produces a product of conjugates. So factoring a difference of square binomials, here's our squares. Binomials produces conjugates. So this is a difference, it's negative. We have our conjugates, our sum and our difference. So example 1. We just have to think, okay, well, x would be x times x. 49 would be 7 times 7. So we could say that's x squared minus 7 squared. And it has to be in the form of conjugates, so that means we're going to have a plus and a minus with each of these. So it's going to be x, x, and 7, and 7, just like that. And that's it. We could have gone through and said, well, what could we multiply together and want this to get our AC of negative 49 when our B value is equal to 0. Well, we're multiplying a positive 7 and a negative 7, because when we add those together, they're 0, and we multiply them, they get negative 49. We could go through that whole long process like we did yesterday, but we can also just recognize that there's a pattern here. This is how it will always work out when we have perfect squares. So next up, for example 2, we have 5 minus 125x. Now 5 and 125x squared are not perfect squares, but we can begin by factoring out the common factor of 5. When we factor out the common factor of 5, we end up with 1 minus 25x squared. Well, 1 times 1 is 1, and 5x times 5x is 25x squared. It's a difference, so we're going to have a result of conjugates. And so we're just going to have our 1 plus 5x and our 1 minus 5x, and we have to remember that we factored out this 5, so it has to stay out in front there. So really not too much different than what we did yesterday. We're just looking for these patterns to help our steps go more quickly. So example 3 says factor 36x to the 6z to the second minus 64y squared. Let me go ahead and advance my book here to example 3 so I can follow along. So we're up at the top of the next page now. So again, we could go ahead, because we do have 6 times 6 is 36, and 8 times 8 is 64, but we also have a common factor, and if there is a common factor, we should always factor that out first. So it says begin by factoring out the common factor of 4. So when we factor 4 out, we end up with 4 times the quantity of 9 times x to the 6, z to the second, minus 16y to the second. Now, we have smaller numbers to work with. This is even better. Let's see. So we would have 3 times 3, x to the third and x to the third, and z and z. So we're just splitting this down into 2 identical terms. We're making this, we're kind of like taking the square root of this whole term. Likewise, we have 4 times 4, y times y for our y squareds. So 3x to the third z squared minus 4y squared. And then we can say, well, it's going to be our conjugates. So you just do 3x to the third z plus 4y and 3x to the third z minus 4y. And remember that we factored out that 4, so it has to go out in front. So it says any binomial that is a sum of squares a squared plus b squared cannot be factored using real numbers. For instance, they give us an example in your book of x squared plus 25. So we could rewrite x squared plus 25 as x squared plus 0x plus 25, where we would have to look for factors of 25 who add up to 0. But there are no factors. Positive 5 and positive 5 would give us 10, not 0. And because this is a positive, that means that we can't find a pair like we were doing for the last set. So it says earlier we studied this. That's what we were talking about in the lesson warm-up, where it's x plus y squared is equal to x squared plus 2xy plus y squared. Same here with our difference of a square. So factoring perfect square trinomials literally looks like that same exact formula that we were using, except switched around. It's just flip-flopped. So we'll start out with something that looks like a squared plus 2 times ab plus b squared, and it'll end up looking like a plus b squared. Likewise with the difference, a squared minus 2ab plus b squared is what we'll start with. We'll end up with a minus b squared. So for example 4, it says factor x squared plus 10x plus 25. So let's take a look at how we actually go about doing this. It says the first and last terms are perfect squares. We can confirm that. So we have x times x would give us, or x squared would give us, the square root of that would be x. Square root of 25 is 5. And it says the middle term is twice the product of their square roots. So here's our square roots. We're going to take those and multiply by 2 times 2. So we have x times 5 times 2. I apologize, my other computer stopped working, so I'm just using a mouse right now, so it's going to be a little sloppy, so just bear with me for these last couple examples. So we have the x times the 5 times the 2, that gives us our 10x. That's our middle terms here. So there we go, we have our x squared plus 2x times 5 plus 5 squared. So we can just say that is our first term plus our second term, our last term squared. So our first term, our last term squared. All we had to do was confirm this here in the middle, and then we know it's going to be our first term plus our last term, and then squared. Example 5. Factor 12x squared minus 36x plus 27. Now, we can't take the square root of 12, but there is a common factor that we can go ahead and take out here, which is 3. So we're going to factor out 3 first. So that gives us 3 times 4x squared minus 12x plus 9. Now we can take the square root of 4x squared. That would be 2x. The square root of 9 would be 3. And then let's just confirm 2x times 3 would be 6x times 2 would be 12x. We have to deal with this negative here. And we deal with that negative by just making it a minus whenever we take the square of our binomial. And then, of course, we have to remember that 3 that we factored out at the beginning. So when you have a minus sign between your first and second terms, that's when you have the difference of a squared binomial. And example 6. We're going to factor this one as well. So the first and last terms are perfect squares. The middle term is the opposite of twice the product of their square roots. So our first term square root was x to the third, y to the second. Our last one was 4z. So that's what we have right here and right here. Then we have our first term times our last terms times 2, and it's a negative. So we just use that negative sign right there. So we have x to the third y squared, our first term, minus our second term, 4z squared. So for homework, let's see here. Go ahead and do 2 through 20 even, and then if someone is there with you, go ahead and go over them with them. So that's your classwork for you to practice right now. 2 through 20 even. And then for homework, let's do 21 through 34. So homework 21 through 34. Remember, email me if you have any questions. It's rritchie@mymariah.org. And then, yeah, I will not be there on Friday, but you will still have your quiz. You also have a Bible quiz and your verses due, so make sure you're studying for that. And I will see you Monday. So have a good weekend.